Our goal remains the same today. We're going to be solving a system of equations. This time we're going to do so algebraically by substitution. By way of review, here are our 4 steps. SSSC. First, we're going to solve for one variable in one equation. Then we're going to substitute whatever we get into the other equation, and we're going to solve for. So solve for, substitute, solve for. Then we're going to substitute the value anywhere. This specifically says go back to step 1, but really you can substitute it anywhere, meaning it can go back to the original problems or here. It doesn't matter. Then we're going to solve for the remaining variable, and our last thing to do is to check our solution by substituting it into both there. So let's look at this problem here. So as we see here, this one is easiest to solve for because it has a coefficient of 1, which means all we have to do is add the 4y to both sides. So in doing so, my next step is simply this, 4y minus 1. I just added 4y to both sides. Now, what do I do with this right there? Good. So we are going to take that. You don't have to draw all these arrows. I'm just drawing this right now so that you can see it. But life's probably easier without the arrows. So we are going to substitute. Now I say 2, instead of saying x, I say 2 times 4y minus 1 plus the 2y equals 3. Now I can distribute. Again, we don't need the arrows and the arcs, but if that helps you, then do it. 8y minus 2, don't forget that minus 2, plus 2y equals 3. I'm going to combine like terms to get 10y, and while I'm there, I'm going to add the 2 to both sides. And lastly, I'm going to divide, and in this case, I get 1/2 or 0.5, whichever you prefer. A common mistake people make is when we do the division, 5 divided by 10, people will often say, oh, look, 10 and 5 divide. So then they jump straight to a 2. So beware of that. Don't make that mistake. If you did make that mistake, the fortunate thing is the check will show you that it's wrong. So you have to go back and make changes. All right, so now that I have a y, what am I going to do with the y? So we are going to take that value and plug it in. Again, you don't need the arrows. I'm just going to show you the arrows right here, just to show you where things go, but you don't have to do all that. So let me just label my steps real quick here. Step 1, I solved for something. Then step 2, I substituted and solved. So now we're in step 3. So now we plug it in. So I get x equals 4 times 0.5 or 1/2 and minus the 1. So x equals 2 minus 1. So x equals 1. So I'm claiming that my solution is 1 comma 1/2. If you want to write it as a decimal, that's fine too. I'm claiming that's my solution, so step 4 is for me just to check. And remember, when we check, we have to check both equations to make sure it works. So, plugging things in, 2 times 1 plus 2 times 1/2 equals 3. And the other one is 1 minus 4 times 1/2 equals -1. So here I get 2 plus 1 equals 3. 3 equals 3, and it's a check. Here I get 1 minus 2 equals -1. -1 equals -1. It's a check, so let me commit to it. And there's my solution. Now let's look at an application of how this can be used. Again, not how you will use it. I have no clue what your life holds for you, but in case you ever come across grapefruits. All right, suppose you bought 8 oranges and 1 grapefruit for a total of $4.60. Later that day, you bought 6 oranges and 3 grapefruits for a total of $4.80. So what's the price of each type of fruit? All right, so let's set up an equation here. Notice that if I say O for oranges, this will be the number of oranges. And if you don't prefer the O because it looks like a 0, then choose something else like an X or a Y. Then I'm going to choose G for the number of grapefruits, excuse me. And what's my mistake? All right, so out of habit, I went to number of grapefruits and so in this case, it's going to be the cost. It's actually the cost of the grapefruit, or of one grapefruit. So the unit price here. Okay, but the process is still going to be the same. So 8 oranges, so 8 times the cost per orange. Again, your handwriting is important here. If you make your O too large, you're going to think that says 80. Plus 1 grapefruit is going to be a total of $4.60. Now, historically, so far, we have been stacking our system, right? So look at these problems up here. The systems are stacked. The system is stacked. The equations are stacked. They don't have to be. They don't have to be stacked. In fact, I'm going to save some time just by not stacking them. So I'm going to put them side by side here because one's going to be solved for, then one's going to be substituted in. Notice that it's quick to tell that I'll probably solve for this one right here because of the 1. So let me go ahead and write the other equation. 6 oranges plus 3 grapefruit is going to be $4.80. So I'm going to subtract 8 oranges, 8 oranges from both sides here. And so my result is this, 4.60 minus 8 oranges here. Oh, but Swenson, don't we have to have this in slope-intercept form or something where the variable comes first? And the answer is no, we don't. All we have to do, the most important part, is to get a variable by itself. Over here, it does not matter about form. So why did I write this as a subtraction? Because I prefer subtraction than negatives. That's just my own preference. Okay, now I'm going to take exactly that, the 4.6 minus the 8o, and I'm going to substitute it over here for g. All right, so 6o plus 3 times 4.6 minus 8o. I'm going to go ahead and drop that 0. And the same thing here. I'm going to drop this 0 and just say 4.8. This may not be your favorite because now we're dealing with decimals, but fortunately you have a calculator, so pull that out if you want to speed your process up. I'm going to distribute here 6o plus 13.8 minus 24o. Again, might not have been a good idea to use the o because it looks like a 0. Just beware. Now I'm going to combine like terms and subtract the 13.8. It's 9. Of course, I forgot a negative in there, so I do have a negative. And then o is 0.5, or in our final answer will be 50 cents there. Now, I knew I forgot a negative because when I subtracted here, but I thought to myself, if I didn't have that second negative, I would have ended up with a negative decimal. Mathematically, you can get negatives, but practically, they're not paying me to take away the oranges. So now I go back over to here, and I'm going to take the g, 4.6 minus the 8 times the 50 cents. So 4.6 minus $4. So in the end, I get 60 cents. So I'm claiming that this is the deal, that it costs 60 cents for grapefruit and 50 cents for oranges. So after I plug things into my calculator and I verified it, this is true per orange or per grapefruit.